Hello friends, welcome to my second lecture on predicates and quantifiers. We are discussing now negation of a quantifier. We have seen that there are two quantifiers, existential quantifier and universal quantifier. So, let us first discuss the negation of universal quantifier. Let us consider the proposition all people are honest. Okay. If M denotes the set of all people, then we can write this proposition as for all x belonging to M, M is honest. This statement will become false if we say that there is a person who is not honest. In symbolic form, we can write this statement as there exists x belonging to M such that x is not honest. Therefore, the negation of the statement all people are honest will be there is a person who is not honest, or in symbolic form the negation of the statement for every x belonging to M, x is honest will be there exists x belonging to M such that x is not honest. Thus, negation of for every x p x is equivalent to there exists x negation of p x, where p x denotes x is honest. So, we can say that the negation of a statement with a universal quantifier. Okay. You can see that here it is universal quantifier, this is universal quantifier. So, negation of the a statement with universal quantifier is a statement with existential quantifier. This is existential quantifier. This is existential quantifier. So, negation of a statement with universal quantifier is a statement with existential quantifier. Now, consider the statement it is not true that there is an x with the property p. This statement is equivalent to saying no x has the property p, or all x have the property not p. Hence, negation of there exists x p x. Okay. There exists x p x is equivalent to for every x not p x, negation of p x. Okay. So, the negation of a statement with existential quantifier, this is existential quantifier, this one, this is existential quantifier. So, negation of a statement with existential quantifier is a statement with universal quantifier. You can see this is universal quantifier. So, when we consider negation of a statement with existential quantifier, what we get is a statement with universal quantifier. Now, we discuss De Morgan's laws. So, if p x is a propositional function defined on the domain D, then negation of for every x belonging to D p x is equivalent to there exists x belonging to D negation of p x, and for negation of there exists x belonging to D p x is equivalent to for every x belonging to D negation of p x. So, when you consider negation of universal quantifier, you get existential quantifier. When you get negation of, when you have negation of existential quantifier, you get universal quantifier. Now, the laws which hold for propositions, we have seen that negation of p r q. If p and q are two propositions, then negation of p r q is equivalent to negation of p and negation of q. Okay. And negation of p and q is equivalent to negation of p or negation of q. Okay. So, these laws hold for the propositions p and q, they also continue to hold here for propositional functions p x and q x. So, if p x and q x are two propositional functions, then negation of p x or q x is equivalent to negation of p x and negation of q x, and negation of p x and q x is equivalent to negation of p x or negation of q x. Let us discuss an example. Okay. So, let us determine the negation of each of the statements here. Let us take the first statement. So, negation of for every x p x or there exists y q y. So, negation of this will be giving us negation of for every x p x and okay, or becomes and and we get negation of there exists by q y. Okay. So, negation of this gives us there exists x negation of p x, okay. And then this gives us there exists becomes for every, okay, by negation of q y. Okay. So, negation of for every x p x or there exists by q y is equivalent to there exists x not p x and for every y not q y. Okay. Let us take the second one now. So, negation of there exists x p x or for every y q y. So, this is equivalent to negation of there exists x p x or becomes and for negation of for every y q y, and this gives us negation of existential becomes universal. So, for every x negation of p x, and here we get negation of for every becomes existential. So, there exists by negation of q y. So, this is what we get when we consider the negation of the statement 2. Now, negate the following statements. If there is a riot, then someone is killed. So, let us say let P denote the proposition there is a riot and Q denote the proposition someone is killed. Someone is killed. Okay. Then the given statement, okay, the given statement implies P gives is equivalent to P implies Q. If P, then Q. Okay. So, negation of we are talking about negation of P implies Q, and negation of P implies Q is equivalent to P and negation of Q. Okay. We can verify this by the truth table. Suppose this is P and here is Q, the truth values are T T, T F, F T, F F. Then P implies Q has truth values T, T F. Okay. When P is T, Q is F, then it is F. Okay. When P is F, Q is T, it is T, and when P is F, Q is F, it is T again. Okay. So, negation of P implies Q. Okay. Negation of P implies Q is for T it becomes F, F becomes T here, and this F T becomes F, and this T becomes F. Okay. Now, P and not Q, let us see. Not Q has truth values F, T, F, T. Okay. So, P and Q. Okay. We can find the truth values of P and not Q. P and not Q. Okay. P and not Q. P has truth value T, Q has not Q has truth value F. So, P and not Q will have truth value F. Okay. And then P has truth value T, Q not Q has truth value T. So, P and not Q will have truth value T, and then P has truth value F, not Q has truth value F. So, P and not Q will have truth value F, and then P has truth value F and not Q has truth value T. So, P and not Q will have truth value F. Okay. Now, let us see whether the truth values of P and not Q are same as the truth values of not P implies Q. Okay. So, here you can see this is F T F F, okay, and here also we have F T F F. Okay. So, not P implies Q is equivalent to P and not Q. Okay. So, not P implies Q is equivalent to P and not Q. Now, so what now? So, from this now let us write it is negation of P implies Q means negation of P implies Q means it is false that if there is a riot, then someone is killed. Negation of P implies Q says it is false that if there is a riot, then someone is killed, okay, which is equivalent to there is a riot and it is false that someone is killed. So, this is equivalent to there is a riot and it is false that someone is killed. Okay. Because we have negation of P implies Q equivalent to P and not Q. So, from P and not Q we can say that P denotes the proposition there is a riot. So, there is a riot, this is end, okay, this notation is end, and not Q means it is false that someone is killed, because Q is denoting the proposition someone is killed. Now, this is equivalent to saying that there is a riot and everyone is alive. Okay, everyone is alive. So, negation of the statement if there is a riot then someone is killed is the statement there is a riot and everyone is alive. Now, let us look at the second statement, it is daylight and all the people have arisen. Okay. So, let us do it like this, it is daylight, let P denote it is daylight. Okay. Let P denote the proposition it is daylight, all the people have arisen. Okay. Let Q denote the statement all the people have arisen. Then the given statement symbolically in the symbolic form we can write as in symbolic form the given statement can be written as P and Q, it is daylight and all the people have arisen. So, in symbolic form we can write the given statement as P and Q. Now, we want to find negation of the given statement, that is negation of P and Q, okay, and this is equivalent to negation of P or negation of Q. Okay. So, by De Morgan's law. So, this is negation of P or negation of Q. Now, so let us now write in the let us write the corresponding statements. So, negation of P and Q means it is false that it is daylight and all the people have arisen. Okay. So, negation of P and Q is the statement, it is false that it is daylight and all the people have arisen. Now, this is equivalent to negation of P and or negation of Q. So, it is false that, or negation of P means it is not daylight, it is not daylight. Negation of it is daylight means it is not daylight, okay, or all the people, negation of Q means all the people have not arisen. Okay. So, this is equivalent to saying it is night, it is not daylight means it is night, or some people have not arisen. Because negation of all is some. Okay. A negation of universal quantifier gives existential quantifier. Existential quantifier denotes there exists or some. Okay. So, some people have not arisen. So, negation of P and Q is the statement it is not, it is night or some people have not arisen, that is the negation of the given statement. Now, let us go to propositional functions with multiple variables. Let us consider a propositional function p x by with more than one variable x, y and so on. If such an expression is preceded by a quantifier for each variable x, y and so on, if it is preceded by a quantifier, then the quantified expression is called a statement. Okay. It is a statement and it has a truth value T or F. Otherwise, it is an open statement. Okay. If the propositional function p x y is not preceded by as many quantifiers as the variables are there, okay, then it will be called an open sentence in the variables without quantifiers and it will have a truth set T p. Okay. So, let us discuss some examples on this. Determine the truth value. Okay. We have to determine the truth value of each of the following statements. Now, in each of these three statements you can see that we have two variables x and y, and the propositional function x square less than y plus 1 is preceded by two quantifiers, there exists and for every. Okay. Here also this propositional function is preceded by two quantifiers universal and existential, and in this case, okay, this propositional function is preceded by two universal quantifiers. Okay. So, there are two variables in the propositional function. Propositional function is a function of two variables and it is preceded by two quantifiers. So, every case here and every example 1, 2, 3 okay, is a statement. Now, let us find the truth value okay, of the first statement. Okay. We are given that 1, 2, 3 is the universal set. Okay. So, you can see we have x, there exists x for every y x square less than y plus 1. Okay. If we take x equal to 1, if we take x equal to 1, then for every y belonging to 1, 2, 3, the inequality x square less than y plus 1 is true. Okay, because y can take value 1, if y takes value 1, then we are taking x equal to 1, so 1 will be less than 2, and if we take y equal to 2, then again 1 is less than 3, okay, and when y is 3, then 1 is less than 4. So, if we take x equal to 1, then for every y belonging to 1, 2, 3, x square less than y plus 1 is true. Hence, the first statement has truth value t. Okay. So, first statement truth value is t. Okay. Now, let us look at the second statement. For every x there exists y for every x there exists y such that x square plus y square less than 12. Okay. Now, x is taking values 1, 2, 3. Okay. X is taking values 1, 2, 3. So, we need to find one y such that x square plus y square is always less than 12. Let us take y equal to 1. Okay. Let us take y equal to 1. Then x square plus y square less than 12 is true for every x belonging to 1, 2, 3. Because if x takes the value 1, then 1 plus y square, y is 1. So, 1 plus 1 is equal to 2, 2 is less than 12. When x takes value 2, then 2 square is 4, 4 plus 1 is 5, 5 less than 12, and when x takes the value 3, 3 square is 9, 9 plus 1 is 10, 10 is less than 12. So, the truth value here is t. Okay. Now, let us look at the third statement. For every x and for every y, x square plus y square is less than 12. Okay. So, third statement, let us look at the third. So, let us take x equal to 3, okay, y equal to 2. Then 3 square plus 2 square is equal to 13, okay, which is not less than 12. It is greater than 12. Okay. So, x square plus y square less than 12 is not true when x is equal to 3, y is equal to 2. Okay. So, for every x, for every y, x square plus y square less than 12 is not true. Therefore, the truth value is f. Okay. So, there are 3 statements. The first 2 statements have truth value t and the third statement has truth value f. Now, let us take another example. Let us take a equal to 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay. Consider each of the following sentences. So, let us consider these 4 sentences. If it is a statement, then determine the truth value. If it is a propositional function, determine the truth set. Okay. Truth set means TP. Now, let us see here, we have 2 variables x and y, okay, and the propositional function is x plus y less than 14, okay, x plus y less than 14. It is preceded by 2 quantifiers, okay. There exists and for every, the universal quantifier and the existential quantifier. So, it is a statement because there are 2 variables, okay, and this is preceded by px, this is px, px is preceded by 2 quantifiers, and here we have again 2 variables, but there is one quantifier which is the universal quantifier. So, number of quantifiers are not 2, okay, and therefore, it is an open sentence, or you can say it is a propositional function. Okay. In the example 3, we have again 2 variables x and y and we have 2 quantifiers. Okay. Both of them are universal quantifiers, and in the fourth case also we have 2 variables x and y and there is only one quantifier which is existential quantifier. So, this is also propositional function. Okay. Now, here we can see, first let us look at this. For every x belonging to A, there exists y belonging to A such that x plus y less than 14. Let us find its truth value because it is a statement. So, it will have a truth value. Okay, x can take values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Let us take y equal to 1. Y equal to 1. Then x plus y less than 14 is true for every x belonging to A, because A has elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So, even if x takes the value 10, 10 plus 1 is 11, 11 is less than 14. Okay. So, for all x belonging to A, if by is taken as 1, then x plus by is less than 14, and so the first statement is true, its truth value is t. Okay. Let us go to the second. It is an open sentence or propositional function. So, x plus y less than 14. Okay. For every y belonging to A, x plus y less than 14. Now, we have to find the set of values of x. Okay. So, T p x belonging to A such that x plus y is less than 14. Okay, for every y belonging to A. Okay. So, y is belonging to A and we want those values of x for which x plus y is less than 14 for every y belonging to A. Okay. So, if you take x equal to 1, then x plus y will be less than 14 for all values of y belonging to A. Okay. So, one value of x could be taken as 1 when x takes the value 2. Okay. Then 2 plus y is less than 14 is true for all y belonging to A. So, another value of x could be 2. Okay. When x takes the value 3. Okay. Then again x plus y less than 14 we want, x plus y less than 14 we want, and we are taking x equal to 3. So, 3 plus y less than 14 or y is less than 11. Okay. Now, y can take any value less than 11. Okay. So, by the values that y can take are from 1 to 10. Okay. So, this inequality is valid. Okay. So, for x equal to 3 also, okay, x plus y is less than 14 for all y belonging to A. Now, if you go one more step, that is you take x equal to 4, then x plus y less than 14 will not be possible, because for all y belonging to A, because when y will take value 10, then 4 plus 10 will be 14, 14 less than 14 is false. Okay. So, T p, the truth set here is the set containing 3 elements 1, 2, 3. Now, let us go to the third statement. For every x belonging to A, for every y belonging to A, x plus y less than 14. Okay. So, you can see here, if I take x equal to 9, okay, and y equal to 8, then x plus y less than 14 is not true. Okay. So, in the third statement, let us take x equal to 9, y equal to 8. Okay. Then x and y both belong to A, okay, but x plus y is equal to 17, okay, which is greater than 14. Okay. So, x plus y less than 14 is not true, okay, and therefore, the truth value of the third statement is false. Okay. The third statement has truth value f. Now, let us go to the fourth case. Okay. So, in the case of the fourth statement, there exists y belonging to A, x plus y less than 14. Okay. So, we have to consider those values of x for which x plus y is less than 14, okay, for some y belonging to A. Okay. So, you can see there exists y belonging to A, y could be taken as 1, okay, y could be taken as 1, and then x can take all values from 1 to 10, x plus y less than 14 will be true. Okay. So, T p is equal to set of all x such that x plus y is less than 14 for some x, for some y belonging to A. This is what we want, okay, x belonging to A, x belonging to A. Okay. So, we can take y to that element y belonging to A as 1. If we take y belonging to A as 1, then for all x belonging to A, okay, we will have x plus y less than 14. So, T p is equal to A. Okay. This is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So, T p in this case will be the universal set A. Now, let us go to the next example, negate each of the following statements. So, negation of there exists x for every y p x y. So, this is equivalent to existential quantifier becomes universal quantifier. So, for every x and then for every becomes there exists y such that negation of p x y. Okay. For negation of for every x for every y p x y is same as for every universal quantifier becomes existential quantifier. So, there exists x, there exists y, negation of p x y. Okay. Then negation of there exists y, there exists x for every z p x by z. So, here negation becomes negation of there exists means for every y, negation of there exists means for every x, negation of for every becomes existential quantifier there exists z and then negation of p x by z. So, this is how we can find the negation of each of these statements. You can see here these are statements, because here we have two variables x and y and there are two quantifiers. Here also there are two variables and there are two quantifiers. Here there are three variables and there are three quantifiers. Okay. So, they are all statements. Now, negate the following statements. Okay. Let us recall that negation of the propositional functions follows the same rule as negation of the formula for propositions. Okay. So, negation of for every x there exists y p x q x, okay, is equivalent to negation of negation of for every becomes there exists. So, there exists x, negation of there exists becomes for every y and then negation of p x or q x. So, negation of this. So, this is equivalent to there exists x for every y, negation of p x or q x, negation of the two propositional functions p x and q x gives you negation of p x or becomes and negation of q x. Okay. Now, let us find negation of there exists x for every y p x y implies q x y. So, there exists becomes universal quantifier becomes existential quantifier, okay, and then negation of p x y implies q x y. And we have seen that in the case of propositions p implies q, negation of p implies q is equivalent to p and negation of q. Okay. So, we can write this as for every x there exists y, negation of p implies q, p x y implies q x y is p x y and negation of q x y. Okay. Now, let us go to the third. So, negation of there exists y, there exists x and then p x and negation of q y. Okay. So, negation of there exists becomes for every y, negation of there exists becomes for every then x, then negation of p x and negation of qy. Now, this is equivalent to for every y, for every x, okay, negation of, now we recall that negation of p and q, okay, is equivalent to negation of p or negation of q. Okay. So, this is negation of p x and negation of q y will be equal to negation of p x and becomes or, and then negation of q y. Okay. So, this is equivalent to, okay, this is equivalent to negation for every y, for every x, and then negation of p x. Now, or negation of q y, we recall that negation of p is equivalent to p. Okay. So, negation of q y will be q y. So, we will get the negation of the third statement equivalent to for every y, for every x, negation of p x or q y. So, with that I would like to end my lecture. Thank you very much for your attention.